Lesson 61 is about subsets and subsets of the set of real numbers. And our first question says, given the sets D is equal to 0, 1, and 2, E is equal to 1, 2, 3, and so on, like 4, 5, 6, and so on, and G is 1, 3, and 5, are the following statements true or false? Now, what our first question, A, is saying is, it says is E a subset of G? Is E a subset of G? And this is a question. So this symbol, this sideways capital U, it means a subset. So is E a subset of G? Well, if we look at E, that's 1, 2, and 3, 4, 5, and 6, and so on. And G is 1, 3, and 5. It's saying, is every member in E within G? So G is only 1, 3, and 5. So E has things that are not within G, so the answer for our first question would be false, because E is not a subset of G. Now our next one is G a subset of E? So E is 1, 2, 3, 4, 5, 6, 7, and G is only 1, 3, and 5, but everything in G happens within E, so G is a subset of E. So this must be true. Then we have D. Is D a subset of E? Well, D is 0, 1, and 2, and E is 1, 2, 3, 4, and 5. So does everything that happens in D happen in E? Well, no, it doesn't, because E does not contain the 0. So D is not a subset of E. We could say that this one is false. Let's look at some more examples. Got a few definitions we need to review. The first is a rational number, and a rational number can be expressed as a ratio, and a ratio is just another word for a fraction. So examples of rational numbers might be like 7, because 7 can be expressed as 7 over 1. Or maybe we have negative 3, because that can be negative 3 over 1. We could also have negative 1 and a half, because that could be expressed as negative 3 halves. Anything that can be expressed as a fraction is a rational number. Now an irrational number is a number that cannot be exactly expressed as a ratio. And one example is pi, because pi is equal to 3.14159 and so on. It never ends. There's never a pattern. So it can't be exactly expressed as a ratio. Another example might be to say the square root of 3. Because if we broke down the square root of 3 to a decimal, the decimal would never repeat. It would just continue on and on and on and on. Let's look at a few more definitions. Counting numbers? Well, counting numbers are also called natural numbers, and they're the set of like 1, 2, 3, so on. Whole numbers? Well, whole numbers are counting numbers, except they also include 0. And integers are whole numbers and their opposites. Now integers is a neat one because it has a very neat symbol. And the symbol for integers is a z that looks like this. It's a z, but it's got a double diagonal. So, kind of made that a little too thick there. Let's erase it. The double diagonal for integers looks like this. And it's a z, well, you can check your textbook on this one too, but it's called a z because the German word for integer is Zahlen. And if you can say that better than me, please do so next class. Now if we move backwards quickly to our last slide, rational numbers, okay, and irrational numbers, they're both types of real numbers. And when we look at the subset of real numbers, it includes rational numbers and irrational numbers. And then the rational numbers include counting numbers, whole numbers, and integers. And we'll review this more in our next class, because it's a really important concept. Let's look at a few more questions. A says 1/2 is a subset of which of the real numbers. So this just means is a subset of which real numbers. We've got that in our braces in order to make it clear to understand. So 1/2. That's a ratio, so that must be a rational number. and a rational number is a type of real number. Well, 1/2 is definitely not a counting number, it's definitely not a whole number, and it's definitely not an integer. So for A, the only subsets of the real numbers that 1/2 belongs to would be their rational numbers. 3 times the square root of 2 belongs to which subsets of the real numbers? 3 times the square root of 2. Well, the square root of 2, if you think about what the square root of 2 is, well, it's not a perfect square, it has no whole number answer. If it has no whole number answer and it's a square root, then it must be a decimal that doesn't ever repeat or doesn't ever end. So if we multiply a decimal that doesn't ever repeat or doesn't ever end by 3, we're still going to get a decimal that doesn't ever repeat or doesn't ever end. So this must be an example of an irrational number. And any square root or any root that does not give you a whole number answer or an integer answer will always be an example of an irrational number. So let's say we had the square root of 7. Well, it's not a perfect square because it doesn't give us a whole number. So this must be another example of an irrational number. Let's look at our next slide. Lesson practice will be on page 251. Make sure you've got your notes complete, and I'll see you during our next class.